My dear students, a very good morning to all of you. Welcome in online classes. Today we talk about the application of electric flux. This is Gauss law. In previous video, we talk about or we discuss what is electric flux, how we can calculate electric flux for a closed surface and a open surface. Its surface may be spherical or cylindrical. So if there is a particle having charge q, so this charge will making electric field in all directions like as football. So electric field is in all the directions. Now we enclosed this charge on in the surface of any shape. This surface considered as any shape like as the electric field line linked with this surface. The quantity of electric field line linked with this surface is known as electric flux. How we can calculate how much the electric flux is there? We can find out in previous video. Electric flux phi E is equal to 1 upon phi E is equal to E dot A, or we can say E dot EA cos theta. So phi is equal to E dot ds. Gauss law states that electric flux linked with the closed surface. It is a closed surface. Gauss law applicable for only closed surface. Gauss law states that electric flux linked with a closed surface is 1 upon epsilon naught times the charge enclosed by the surface or inside the surface. These two things are very important. First is one enclosed and another is one closed. So this statement we can write as phi E is equal to 1 upon epsilon naught multiply with q. So E dot ds is equal to q upon epsilon naught. We know that electric flux phi E is equal to E dot ds. For Gauss law, so many conditions. First is one, it is true for closed surface only. It is true for closed surface only. Second is one, all the charges consider inside this surface. Let us suppose here will be a charge plus q, here will be a charge plus 2q, here will be a charge 3q, minus 4q here, minus 6q here. So these all charges are considered inside the surface. If the charge outside this surface, this makes electric flux, but the net electric flux will be 0. Why? Here let us suppose this charge is plus 2q. It makes an electric field line. Plus 2q. So this makes an electric field line here from linked with this surface. So this is the flux, and we can write as here this electric field lines enter the surface and goes from here to the out of the surface. So incoming line is equal to outgoing line. So this incoming line is equal to outgoing line means net electric flux will be 0 for which charge, which is outside the surface. Another is one, Gauss theorem used with symmetrical surfaces to calculate electric field at a point. Later on we discuss this point. And another is one, Gauss theorem depends upon inverse square law. It is very important. Gauss theorem depends upon inverse square law. Means this modern Gauss law, if the electric field, if we discuss in Coulomb's law holds the inverse square law. If let us suppose Coulomb law does not depends on the inverse square law, then Gauss law will be different. How it is, we can explain in here. Now we prove the Gauss theorem. What is Gauss theorem? Gauss theorem, consider, let us suppose we have a charge plus q, and consider an imaginary surface in the shape of a sphere such that q lies at the center of this sphere, and let us suppose its radius should be r. This surface is known as Gaussian surface. Gaussian surface means imaginary surface, and another is one, it is symmetrical, or we can say homogeneous. So we two things for Gauss theorem. First is one, we considering Gaussian surface, and another we use electric flux. First, for here we have a charge is plus q, and we considering a Gaussian surface. Gaussian surface should be symmetrical and homogeneous. So let us suppose this is the radius, and electric field line, we know that plus q charge here, so electric field lines are in this directions. For this, electric field lines are in this directions, electric field lines are in this directions, and this is the surface. So let us suppose here we have a very small surface ds, and area vector should be radially outward, we know that. So electric field and area vector here makes an angle 0 degree, and we already find out electric field at a point. We know that E is equal to 1 upon 4 pi epsilon naught q upon r square. Now we find out a small flux linked with this small area, that is ds, is, we know that electric flux linked with the surface to a surface area, phi is equal to E dot ds. So here we have d phi is equal to E dot ds, and d phi is equal to E dot ds, and E ds cos of theta we can write it, and E is equal to 1 upon 4 pi epsilon naught q upon r square. Now here we have the angle between electric field and area vector is 0 degree, so we have theta is equal to 0. Now we have cos 0, and ds, this ds, and here is ds. So let us suppose here will be, we have another ds, here will be ds, and so many ds we considering in this surface, that when we integrate all ds, or we can say when sum up all these ds, then we get surface area, and we know that surface area of a sphere is 4 pi r square. So ds is equal to 4 pi r square. So we can say 4 pi r square is closed surface area. So phi e is equal to 1 upon 4 pi epsilon naught q upon r square, taking out from the integral. So closed integral ds values will be equal to 4 pi r square. So we have phi e is equal to q upon epsilon naught. This is proof of Gauss theorem. Now Gauss theorem, why it is Gauss theorem depends upon inverse square law. Why? Because we know that if here in Coulomb's law we study Coulomb's law depends on the inverse square law. Let us suppose here will not be r square, it should, let us assuming here r cube, then we have different type of Gauss theorem expression are here. So this is r cube, let us suppose this is r cube, so we have q upon r epsilon naught. So this Gauss theorem holds inverse square law, and that is very important, and application of Gauss theorem will discuss in another video. So this is Gauss theorem, Gauss theorems and Gauss law. very important for electrostatic. This Gauss law we can application is most important for the point of view of board examinations. Gauss law states that electric flux linked with the closed surface is 1 upon epsilon naught times the charge enclosed by the surface. One is enclosed and another is one closed surface. These are very important and we know that what is the Gauss law. Thank you so much.